To find the exact value of sine and cosine, what you want to do is draw, sketch the angle in standard position. So negative 150 degrees is going to go down, it's going to go clockwise, and so negative 150 degrees is going to be 30 degrees short from 180 degrees. So your reference triangle is going to make a 30-degree angle. So the cosine of 30 is the x value. So the x value using the special right triangle is going to be root 3 over 2. So root 3 over 2. However, the cosine is going to be negative in this quadrant, so it's going to be negative root 3 over 2. And the sine is going to be also negative in this quadrant, so it's going to be negative 1/2. So the distance right here is, the distance is positive, and this distance is positive, but we're talking about this coordinate. So we had to go left root 3 over 2 and down 1/2. So this represents the cosine, this is a sine. Cosine is always the x, sine is the y. When you're converting to radians, you want to multiply by pi over 180. So the 45 goes into 180 4 times, so this is going to be pi over 4. And same with negative 310, I'm going to multiply by pi over 180. I can cancel out the zeros, and so 31 over 18 doesn't reduce any further, so the answer is just going to be negative 31 pi over 18. So we can measure angles in degrees and radians, so make sure you're comfortable with both. Convert into degrees. To convert into degrees, you want to multiply by 180 over pi. So I would, to do this without a calculator, I would divide 180 by 4 first, which is 45, and then multiply 45 times 5. So 45 times 5 is 225. And over here, I'm going to multiply it by 180 over pi. So again, I would divide 180 by 6 first, which is 3, and multiply it by 7. So negative 210 degrees. And the pi's would cancel out again. Number 33, find the exact length of the minor arc. So arc length is going to be radius times radians. So arc length is S equals r theta. Theta has to be in radians. So this arc length is going to be the radius, which is 4, times 120 degrees in radians. So I'm going to convert this to radians, which is 12/18, which is 2/3. So this is 2/3 pi. So then I have 4 times 2, which is 8 over 3 pi. This is the exact length. If you want to find the approximate length, you would actually put this in your calculator. So 8 pi over 3 units. Number 34, find the measure of the angle. So we have that this is the arc length right here. And we have the radius, but we don't know the angle measure. We don't know what theta is. So I'm going to use the formula S equals r theta. So it's going to be 6 equals radius, which is 3 times theta. So dividing both sides by 3 would give me 2 equals theta. So theta equals 2 radians. Remember, it's in radians is my unit. Okay, 35, find the period and amplitude. So period of a sine and cosine function, the formula is going to be 2 pi over b. So b is the coefficient of x. So this period is 2 pi over 6, which is pi over 3. And the amplitude is the absolute value of a, and a is the coefficient of sine and cosine. So amplitude is going to be 1/2. Right here, the period is going to be 2 pi over 1/4. So I'm going to flip 1/4 over, so it's 2 pi times 4 over 1, which is 8 pi. So the period's 8 pi. And then the amplitude is going to be positive 3. Remember, amplitude is always a positive number. It's the absolute value. It's a distance, so it needs to be positive. Okay, for 36, I'm going to find the amplitude, which is 2, the period, which is the coefficient of theta or x, so it's 2 pi over b, so 2 pi because b is 1. The vertical shift is up 3, and the phase shift is you're going to go right pi over 4. So when I graph these, I'm going to, there's a couple different ways that you can do it. You can actually graph 2 cosine theta and then shift each point right pi over 4 and up 3. I'm just going to start at, I know that I went up 3, so it's going to be my new axis, and then my amplitude is 2, so my function is going to oscillate between the red part, and I'm going to start at pi over 4, so that's halfway in between pi over 2 and 0, so that means I'm going to end over here, because my period is 2 pi from here to here, so I just had to extend it. So a positive cosine function, which I have, will start at the maximum, and it will go 0, or maximum 0, minimum 0, maximum. So I had to, within this cycle, I had to go back up to the maximum, and halfway in between I had to have the minimum, and halfway in between the max and the min there needs to be a 0. So now I'm going to graph this like this, and I can keep the pattern going over here to the left. Okay, and then 36, the second one. The amplitude's positive 1. The period is 2 pi over 4, which is pi over 2. My vertical shift is down 1. My phase shift is left pi. And actually, I didn't do the domain and range over here, so I'll go back to this one. Domain is going to be all real numbers because it's going left and right infinitely. And the range is from 1 to 5. And if you want to, you can write that as an inequality too. So going back to this one, I'm gonna go, my phase shift is down 1. So I'm gonna start out my graph down 1 instead. My amplitude is 1, so it's going to oscillate between here and here. I'm starting left pi, so I'm actually going to start right here. And I have to do 1 cycle in between 0 and 2 pi. Or 0 and pi over 2. So if this is my sine function, I'm starting in the middle, and I'm going to make an S. It's going to go 0, max, 0, min. I didn't fit all that right here. Hold on. So it's going to go in between here and here. It's going to be a 0, max, 0, min, 0, max, 0, min, 0, max, 0, min. Keep going. Okay, and you can go to the left too. So the domain is going to be all real numbers again because it's going left and right infinitely. And the range is going from -2 to 0. And then next one, the tangent. So I want to do the period. The period for a tangent is pi over b. So pi divided by 1/2 is actually going to be 2 pi. So if tangent always starts at 0 unless it's been shifted left or right. It doesn't have a phase shift right here. So the tangent of 0 is 0. So it's going to start right here. So if your period is 2 pi, it means that one cycle is going to go from -pi to pi. So one asymptote is going to be pi, and the other one's going to be -pi. So I'm going to call that plus or minus pi. So I'm not done yet. So I'm going to make this and this. The next asymptote is going to go up another 2 pi because the period is 2 pi from pi. So to write my asymptote, I'm going to write pi, and I'm going to add and subtract 2 pi n because my period is 2 pi, so it's going to keep going up. So there's no vertical stretch in this. So halfway between 0 and pi is pi over 2. It's going up 1. If there was a different number in front, like a 3, you'd go halfway in between and go up 3. And it's going positive, so it's going up. So now you want to draw one tangent. And I can continue that pattern. So the next x-intercept right here, let's see. So it looks like this. So x-intercepts are happening every 2 pi. Asymptotes are happening every 2 pi because the period is 2 pi. My range is going to be all real numbers because it's going up and down infinitely. And then number 37, solve by graphing. So you want to make sure that you put in your window, you want to go to your window, first of all, or then you want to make sure that you are in radian mode. Okay, because this is referring to radians. So go to your window, put your window, and the x min is 0, and the x max is 2 pi. And we're going to want to solve this equation, so we're going to put this in our y1 and this in our y2, and you're going to want to see where they cross. So go to your y1 and put 1, or where they intersect, and go to your y2 and put -5 cosine x, close the parentheses, plus 2. So you're trying to look for where this function crosses. So my graph looks something like this. I have a blue line, and then I have this red curve that's crossing twice. So there's 2 solutions. So to get those solutions, I go to second trace. So you do second trace in your calculator, and you're trying to find the intersect, and you're going to go get both of those numbers. So one of them is the x value 1.4, so you only care about the x values, 1.4 or 1.38 depending how you approximate. And the other x value at the intersection is going to be, just a second, it's taking a little bit to slide over, is 4.9. So those are my 2 answers. So this is in radian mode because this is radians. Number 38, if the secant of theta is 6/5, what's the cosine of theta? So remember, secant is the reciprocal of cosine. So the reciprocal of 6/5 is 5/6. Find the exact value of each of these. So secant of 60, I'm going to do the reciprocal of 1 over the cosine of 60. So cosine of 60 in a right triangle, the cosine is going to be the adjacent, so the short side is going to be 1/2. So 1 divided by 1/2 is 2. I actually kind of drew that weird because I should have drew it in the in the coordinate plane. And then the cotangent of 45 is 1 over the tangent of 45. So the tangent of 45 is 1, so 1 divided by 1 is 1. And the cosecant of 30 is 1 over the sine of 30. So sine of 30 is 1/2, so 1 divided by 1/2 is 2. Okay, none of these required us to rationalize any denominators. So just be aware that you could have to rationalize denominators, or you could have situations that are undefined. So undefined would be something like if you had to do, let's see, if you had to do the secant of 90. Okay, or it could also be in radians too, secant of pi over 2. So this would be 1 over the cosine of 90. So on your unit circle, the cosine of 90 is 0, so 1 divided by 0 would be undefined.